Let's talk about indifference curves. So, what are indifference curves exactly? An indifference curve is a graph that shows what combination of two goods will make Hansen, our consumer, the most satisfied. We measure satisfaction in utility, which is broken down into theoretical units called utils, and utils are based on individual preference. For this exercise, we'll be analyzing three curves on the graph: I1, I2, and I3. So let's focus on I2. This line represents Hans's optimal outcome. Since he is unemployed, I offer him an allowance each week, and I2 shows the maximum amount of goods he can afford. Point A represents 6 servings of Binkies and 3 tuna waters. B, less Binkies, more tuna water, and C, with more tuna water and less Binkies. These represent points of indifference. In other words, each point on the I2 curve indicates that Hans, in fact, does not give a damn whether I give him tuna water or Binkies, as they will offer the same amount of overall satisfaction or utility. Now, if we look at I1, this is where Hans would be able to put aside some of his leftover allowance. However, since cats care more for food than money, his maximum possible utility will be achieved by spending all of his money on food. Point D represents a point of less Binkies and less tuna, and therefore less utility. Likewise, on I3, if Hans is receiving more Binkies and more tuna water, his overall utility increases. Unfortunately, Hans is still unemployed and cannot afford that luxury. Therefore, I2 represents his point of highest possible utility. So, how do we calculate utility and those points on the curve? For the sake of clarity, economists assume that consumers make their decisions rationally and with forethought, otherwise known as the rational choice theory. Why is that important? In this case, it's because we need to assume that Hans is truly indifferent between Binkies and tuna water. In other words, one can substitute the other. Once we know that, we can use the marginal rate of substitution to calculate the utility in Hans's decision. Without using calculus, we can map these points on the graph to see that from point A, Hans is willing to forego 2 servings of Binkies for 1 dish of tuna water. As we move along the curve to point B, however, Hans is only willing to forego 1 serving of Binkies for 1 tuna water. Why is that? As he consumes more of one good, Hans's rate of utility will fall. As a matter of fact, if he consumes too many Binkies, he'll start feeling nauseous and he'll actually lose utils. This is called the diminishing marginal utility. If Hans has more tuna water, he'll be less willing to forego his Binkies. Let's review the properties of indifference curves. They are bowed inward because the marginal rate of substitution changes depending on the amount of goods a consumer has and their willingness to substitute between them. Because all of the points on one line represent equivalent satisfaction, even if there were infinite curves on one graph, they could never intersect. Due to the diminishing rate of substitution, they are downward sloping and convex to the origin, meaning the line flattens as it goes right and gets steeper on the left. Higher indifference curves mean higher utility levels. That is, higher numbers mean there must be greater value to the numbers on the curve at the same rate of indifference. While indifference curves look much the same, they are based on individuality and preferences. Thanks for watching. Good luck on your finals.
Dude, get a job!